In section 13.2, there's not very much beyond 13.1. If you can do 13.1, you can do 13.2. So 13.1 would say, okay, the derivative of a function is x to the power of 4. What was the function? So they say dy by dx equals this. What's y? And that's a bit of a clunky way of describing a process. Why can't we say x to the power of 4, integrate this please? Where's my notation for integrate this? And there is a notation for integrate this, and it works like this. It goes that and that. So there are two symbols, this sort of integral symbol and then a dx at the end. And you should think of those as a sort of open and closed brackets. So it's a bit like we've got a set of brackets and everything inside the brackets is what needs to be integrated, okay? Now those are sort of odd looking brackets, aren't they? One that's a squiggly s and one that's a dx. The dx is like the dy by dx, and it's sort of, you know, it comes from the same sort of idea. And it's asking for, the x is important because it tells you that x is the thing you differentiate with respect to. So we're saying integrate x to the power of 4 with respect to x. That's how we'd read this. What does it mean to integrate with respect to? Well, I could say, if I've got something like this, x squared times a to the power of 3, is the x the variable there? Am I supposed to increase the power on the x and treat the a like a constant? Or is the x the constant and the a is the variable? Okay, so in this case I can integrate that with respect to x, or if it said with respect to a, then I'd be treating the x like a constant and a is the thing that I'm integrating. Okay, so if you've got more than one letter in there, the letter that's not an x is just a constant, and you can treat it like a number. That's not hugely important for the moment though. Don't panic if that's slightly confusing. You just get on with the examples and you'll see it's not too bad, because we're always going to differentiate, we're always going to integrate with respect to x. So these are like a set of brackets. This squiggly sign, this integral sign, is a deliberate sort of S-shaped thing, and we'll see why a little bit later on in the chapter. But integration, the book hasn't told us yet, and I haven't explained yet, is to do with areas under curves. And areas under curves we can think of as being, you know, if I want the area under this curve between here and here, then I would add up all of these little strips here and I'd get a rough answer. And then if I make those strips thinner and thinner, I get a better and better answer. So an area under curve I can do by summing things together. And if you're summing things, if you haven't met this notation yet, we often use that. You probably have met that notation on a spreadsheet, right? It's the button you press to add up all the numbers in that column. And that is called a sigma, a Greek letter S. So a sigma or an S for sum up as in sum up these strips. We don't want to sum up these strips because integration is finding the area under the curve. And so the symbol we have for integration is a sort of corrupted S, right? And that's on purpose. That's a little side note. We don't need to know it for section 13.b, but it helps us to know where we're heading in a little while, okay? So for section 13.2, exercise 13b, there really is only one new idea, which is this integration symbol. So taking the first example, x to the power of a half plus 2x cubed, that's the thing I want to integrate, so I say integrate that with respect to x, okay? When we integrate that with respect to x, increase the power, and now we can say, well, when we integrate that with respect to x, we do get the following thing, so we can now use an equal sign. X to the power of 3 over 2 divided by the new power, x to the power of 4, divide this term by the new power, and don't forget our constant of integration. Okay, and that is everything we need, really. I mean, if you look at the rest of example 4, they're all written down there for you, part A, B, C, and D. Example 5 is, we end up with things like, 2 over x cubed. We need to rewrite it as 2 times x to the power of minus 3, because again, to integrate, we need to put things in this form, something times x to the power of something. So in example 5, things aren't in that form, and we need to rearrange them into that form. I'm not going to go through these examples now, because that's getting back to chapters 1, 2, and 3, I think, where we're dealing with surds and indices and things like that. So rearrange it to the power that looks nice, get used to this new notation, and that's us done with section 13.2.